And now here is heat of formation from the following information. So some equations or some reactions we cannot actually do in the laboratory just from its elements. So we have to find the heat of formation of glucose here, that is here. We cannot calculate just by combining carbon, hydrogen and oxygen from its element to form glucose. So what we will do is we will take the combustion reaction with delta H value, and they will give the delta H formation of some compounds here, and then we can calculate the heat of formation of that particular substance. So if you have questions like this, what we have to do is we should know what is this one means. It's on the right side of the equation. If it is the right side of the equation, we know that is exothermic reaction. If it is exothermic reaction, we know how to write it in terms of delta H. So I will just rewrite the equation, and I will rewrite this one as delta H equal negative 2800 kilojoules. Okay. That is nothing but we know the formula delta H equal sigma of delta H of products minus sigma of delta H of reactants, correct? So sigma of delta H of products we will calculate from the values given here. There are 6 carbon dioxide, so 6, and each carbon dioxide they give negative value here, negative 393.5, and we have 6 of water, 6 times negative 285.8. Okay, so the sigma of products minus reactants. So for the reactants, we don't know for glucose, so we will just write heat of formation of C6H12 or 6, we don't know, plus oxygen is elemental form, so we will just write 0. So what is delta H? Delta H is negative 2800. Okay, so now we can simplify to get for the glucose. Let us do that. So negative 2800, that equals 2361. That's going to be a negative as well. Plus, let's see, 6 times negative 1714.8 minus delta HF C6H12O6. All right, now we will just add this together, and that means 2361 plus 1714.8, that equal negative 4075.8 minus delta HF of glucose. That is nothing but negative 2800. So we can take this one to this side, this one to this side. So that means on both sides, so delta HF of C6 H12 or 6 equal negative 4075.8 plus 2800. That will be minus 2800, 1275.8 kilojoules per mole. That's going to be the delta H formation of glucose. So this is our fourth method. And now the last method, the fifth method, which is called Hess's law of heat summation. So they will give in the question, there will be an equation, the required equation, and you will have 2, 3 equations with the delta H values given. So we have to add them together in order to get the delta H of the required equation. So sometimes to get the required equation, you may have to flip the equation. Okay, when you flip it, the delta H value, you can see here, the sign also should, delta H value sign also should flip. Okay, if it is, value also changes, opposite. And sometimes you have to multiply with a number, the whole equation, and then again multiply delta H with that number. So what does that means? I will explain in the next slide by solving this equation. Okay, now let us solve this one. So we can see that from the given equations, we have, let us number it. The first one, equation number 1, second equation 2, equation 3. So when you look at the required equation here, for which we have to find the delta H, we can see carbon on the left, hydrogen on the left. So when you look at that second equation, carbon is on the left, and the third equation, hydrogen is on the left, so that is clear, and C2H2 on the right side. So what we will do, we will flip the first equation so that we will get C2H2 on the right side. So if you can see that one, we can that first equation, the flipped equation here. Okay, so 2CO2, that is the product here, and H2O product here gives the reactants, now the product, C2H2 plus 5/2 oxygen. When you do that one, see the delta H sign negative changes to positive. The values are not changing, only the sign is changing. And now we will see we need 2 carbon. So what we will do, multiply with the 2. So 2 carbon plus 2 oxygen will give you 2 CO2. So delta H value also multiplied by 2. So 2 times negative 393.5. So that is also multiplied, here also multiplied. And hydrogen is on the left. We don't have to do any change because it's already 1 mole of hydrogen molecule here. So 1H2 plus half O2, I will just rewrite that one. And what we will do now, we will start cancelling the same on both sides. And we need carbon, we need hydrogen, and we need C2H2. So it is easy for us to find the one which is not required and maybe on both sides. So I can see 2CO2, 2CO2, correct? And I can see 1 mole of water here, 1 mole of water here, and 2.5 oxygen on this side, and 5/2 is 2.5 oxygen here. So when we cancel, we will have 2 carbon left, 1 hydrogen, and C2H2 on the right side. So when you simplify this number and add them up, you will get 226.7. So multiply these two, you will have a negative value here, and positive value here. And then when you add them up, so let me show you. So this is, and then negative 285.9, correct? And now 1299.6 minus 2.9, 7, 6, 2, and 2. 226.7 kilojoules per mole. These are the different methods of calculating delta H values.